The last molecular reaction we're going to do of alkenes is hydrogenation. You take your alkene, you react it up with hydrogen, and you get an alkane. Alkene to an alkane, it's a reduction. Reaction with hydrogen, it's a reduction. It's also where you go from an unsaturated species to a saturated species. It's an extremely important industrial reaction because if you remember, years ago, saturated fats were bad for you. Now it's unsaturated fats that are bad, as are found in a lot of vegetable oils. You want to saturate them to make them better. So this is an extremely important industrial reaction. However, it requires a catalyst. It requires a heterogeneous catalyst. It requires a metal. Now you can either use platinum at room temperature, nickel, 150 degrees Celsius, other metals. What's important is you have a metal surface for this reaction to take place on. And I want to just see if we can't get that across with a fun little animation. So here is a metal surface, all those little M atoms on the surface. Now when a hydrogen molecule approaches a metal surface, it can break the hydrogen-hydrogen bond and form weak bonds between the hydrogen and the metal atoms. So have a metal surface, put in some hydrogen, and you're going to have lots and lots and lots of hydrogen atoms bonded to that metal surface. If I'd wanted to, I'd have kept drawing them along here, but it got boring to do that. Now the same idea when the alkene approaches. There is our alkene. Again, I'm approaching it flat. Very important that you realize it approaches flat. It approaches parallel to the metal surface. Same idea. You got this pi cloud of electrons there, weak bond. They will bond instead with the metal atoms. So you get the same kind of idea. Carbon atoms weakly bonding to the metal atoms. And of course, now you're getting a little bit of a tetrahedral shape at the carbon, so R1, R2, R3 and R4 are sort of bending away. Now what's really cool is that you can have the hydrogen atom can say to that carbon atom, you know, we got weak bonds here, you and I could have a really strong bond. And so a hydrogen will move, and there's some really lovely studies showing these atoms moving around on the surface, but hydrogen atom can move, get rid of its bond, go to the carbon says, oh yes, let's make a bond, and so we get a carbon-hydrogen bond there. And the same thing can happen to this carbon. Hydrogen comes in, makes a bond with it. Do you know how long it took me to do those animations? I think they're amazing, aren't they? So here is our final molecule, okay, drawn up big from there. What you should notice is that this again is a specific type of reaction. The two hydrogen atoms go on the same side of the double bond. That's the so-called syn addition on the same side. So when you do this reaction, hydrogen itself can't do the reaction. However, you give it a metal catalyst, a heterogeneous catalyst, because of course the metals are solid, hydrogen and your alkenes will be gases. The hydrogen goes to the surface, puts metal hydrogen bonds on the surface. You got hydrogen atoms which will then react with the double bond, but because both of them are coming from the metal surface and the alkene lies parallel to the metal surface, both of those hydrogens go on the same side. Hydroboration, that bromine and the hydrogen can go on the same side, they can go on opposite sides. Bromination, anti, one goes on one side, one goes on the other side. Hydrogenation, both of the atoms that you're adding to the double bond go on the same side. So I said this was our last molecular reaction. The last reactions we're going to look at of the alkenes in the next set of movies are those in which they polymerize. Extremely important industrial process, worth a completely separate set of movies.